Let's talk about the string buffer in Java, a mutable string builder. In the realm of Java programming, the string buffer class serves as a dynamic and modifiable container for character sequences. Unlike the immutable string class, which creates objects for every modification, the string buffer allows you to directly alter its contents without creating a new instance. The primary advantage of string buffer is its ability to be modified. You can add, remove, or replace characters within the sequence without creating a new object. This makes it more efficient for operations that involve frequent modifications to strings. Also, the string buffer is inherently synchronized, making it thread safe. This means multiple threads can access and modify the same string buffer object concurrently without causing data corruption. This is a big win over any of the classes that require additional functionality to be thread safe. Regarding the length of the underlying character array, the string buffer has an initial capacity, but it can grow automatically if necessary to accommodate more characters. This process is called resizing, and it adds a little performance overhead when it takes action. But it also acts conservatively with memory, trying to use only more memory if necessary. This behavior makes stringbuilder suitable for scenarios where the exact length of the string is unknown in advance, but memory efficiency is still a concern. It is possible, though, to set a capacity to a certain size. With this extra step before starting any other operations, resizing can be avoided and therefore reducing the performance overhead for that. On the other hand, it is also necessary to know how big the string buffer needs to be, which may not be possible in every scenario. So how does the string buffer compare to string builder? And why would you prefer to use this one over the other? Both string buffer and string builder are classes in Java that represent mutable sequences of characters. They are used when you need to modify strings frequently, as opposed to string objects which are mutable. That said, the key differences lie in synchronization and performance. Regarding the synchronization, we mentioned that the string buffer is synchronized, while the string builder is not. This means multiple threads can access and modify the string buffer concurrently without causing issues. On the other hand, the string builder is not synchronized, making it faster but not thread safe. If you're working in a single-threaded environment without aiming at concurrency calculations, then string builder is generally preferred for performance reasons. If you're working in a multi-threaded environment though, the choice to take string buffer is the way to go. Alright, let's create a Java code example and see how to make use of the string buffer. Don't worry, I've uploaded the example code that we discussed in this video onto GitHub. This way you can check it out for yourself and make your own test cases with it. You can find the links to the GitHub repository in the video description below. Alright, so here we have a Maven project, and we also have two files for building the application and two files for running the application. The CMD files are for Windows and the shell scripts are for Mac and Linux. Alright, the first thing we want to do is create a string buffer. String buffer, SB, new string buffer. Now let's append strings. This is easily done by using the append method, in which we provide a string. So let's append hello. Let's also append my friend. And now let's print it to the terminal. System out println SB. Alright, let's take a look at what this looks like when executing the application. Let's build and run the application. And here we can see hello my friend. Alright, let's insert a string at a specific index. Let's also announce it. Insert string at a specific index. Alright, inserting strings can easily be done using the insert method, in which we provide an index and the string we want to insert. So let's insert a string. SB insert index 5 and there. Let's print it to the terminal. System out println SB. And now let's take a look at what this looks like in action. Let's build and run the application. And here we can see hello there my friend. But we also see it a second time. Hello there my friend. Why is that? The reason for that is that insert also returns the string that it just changed. And providing SB to the println method also creates the string so that the terminal can output it. Alright, now let's take a look at how to replace a portion of the string buffer. Let's also announce it, replace a portion of the string buffer. And to do that, we're going to make use of the replace method, in which we provide a start index and an end index. And of course the new string that we want to insert. So let's do that. SB replace from index 0 to index 11 and insert the word goodbye. Alright, let's print it to the terminal. System out println SB. Now let's take a look at what this looks in action. Let's build and run the application. And there we can see Goodbye, my friend is the new string. Alright, let's see how to get a substring. Let's announce it. Get a substring. For that, let's create a new string variable, substring, and make use of the method substring, in which we provide a start index and an end index. So in this case, SB substring index, start index 9 and end index 18. Let's also print out this substring. System out println substring and then the substring. Alright, let's see how this looks in action. Let's build and run the application. And here we can see that the substring between index 9 and 18 is my friend. Alright, let's take a look at how to delete characters within a range. Let's announce it. System out println delete characters within a range. And again, we're working with indexes and making use of the delete method. So SB delete from index 7 to index 18. Let's print SB, system out println SB. And again, let's build and run the application. And here we can see the string that's left is goodbye exclamation point. Alright, now let's take a look at how to reverse the order of characters. Let's announce it, system out println reverse the order of characters. And for that, it's very easy. We're just going to make use of the reverse method, sb.reverse, and again print the string that we're left with. Now let's build and run the application. And here we can see the reversed string we now have, where the first characters are now at the end and the end characters are now at the front. Alright, now let's take a look at how to get the current length. Let's announce it, system out println get the current length. And for that, we're going to create a new variable that we call length. It's an int variable in which we put what the length method responds. Alright, let's print it to the terminal, system out println length. And now let's take a look at what this looks in action. Let's build and run the application. And here we can see that the current length is 8. Alright, let's take a look at the capacity, meaning the size that acts in the background, so that values can be put into it. Alright, let's announce it. System out println get the capacity. And for that, we're going to create a new int variable, capacity, in which we put what the capacity method responds. Let's also output it, system out println capacity and the capacity. Alright, let's build and run the application. And here we can see the current capacity, which is 34. Alright, now let's take a look at how to convert the string buffer to a string. Let's announce it, convert the string buffer to a string. For that, we're going to create a new variable, str of type string, in which we put what the toString method responds. Essentially, this is the same as just providing the SB variable to system out println, but here we do it explicitly. Alright, let's print it to the terminal, string and then the string. Let's build and run the application. And here we can see the string that we got is the reverse string of goodbye and the exclamation point. Alright, now let's take a look at how to check if the string buffer is empty. Let's also announce it, check if the string buffer is empty. And for that, we're going to create a new variable isEmpty of type boolean, in which we put what the isEmpty method responds. So let's do a first check. Let's print is it empty now, and then provide the isEmpty variable, which is true or false. And now let's empty it. Let's delete everything that we have in the string buffer. For that, we're going to make use of the delete method. So delete from 0 to the length of the string buffer, which is the last index. And then we'll check again by making use of the isEmpty method. And now let's print the same thing again, isEmpty now, and provide the isEmpty variable. Now let's build and run the application. And here we can see that the first time we checked, the string buffer was not empty, but the second time we checked, it was empty. To sum everything up, we first made sure we understand the basics of the string buffer in Java. We then created a code example in which we appended strings, inserted strings at a specific index, replaced a portion of the string buffer, deleted characters within a certain range, reversed the order of characters, got the current length, got the current capacity, converted the string builder to a string, and lastly checked if the string buffer is empty. So what did you think about this video? Did you like it? Did it bring some value to you? Hit the like button and also subscribe to this channel. This is the best way to get notified about future videos just like this one. My name is Gene. Thank you very much for watching and see you in the next video.